So welcome to chapter 2, which we're going to get into a topic called limits. So when you watch these videos, make sure that your cell phones are put away entirely so that you're not tempted to check your text messages or anything like that. Make sure they're nowhere near you. Make sure you've got your notes out, your guided notes, you've got a pencil, a calculator, and possibly a web browser open, because sometimes we're going to use Desmos in these videos here and there. So what I want to do is just get into this idea of what we mean by a limit with sort of a basic example. We're looking at an example using velocity. Suppose that you wanted to calculate your average velocity as you were to travel along a straight highway. If you were to pass milepost 100 at noon and then milepost 130 at 12:30 p.m., what is your average velocity for this time period? So the idea is that we've traveled, think about on average miles per hour. What did you travel over that time interval? So we traveled a distance of how many miles. If we went from 100 milepost to 130, that would be a distance of 30 miles. And the time interval was a half an hour because we went from noon to 30 minutes. So I'm just going to say 0.5 hours. And then if we simplify that, we get 60, and the units would be miles per hour. This is our average velocity over that time period. Does that mean I went a consistent 60 miles per hour the entire time? No, I could have gone a little faster. I could have gone a little slower, but on average, I went 60 miles per hour during that half hour. So that's my average velocity. In contrast, we'll later talk about something called the instantaneous velocity, which is the velocity at a specific point. If you were driving, like I said, does that mean I went a consistent 60 miles per hour every time I looked down at my speedometer? No, it could have been faster or slower. Suppose I looked at my speedometer and it said at one point I was going 65 miles per hour. That's my instantaneous velocity. If I took a snapshot right at that moment, how fast am I traveling? Let's keep going. Let's talk about the next example. A rock is launched vertically upward from the ground with a speed of 96 feet per second. A famous formula from physics tells us that the position of the rock after t seconds since we've launched it is given by this function. And it says S is the position measured in feet. So that's what you want to pay attention to. S is measured in feet. And of course, time t is measured in seconds. And it says find the average velocity of the rock between each pair of times. So what I'm going to do then is I'm going to say, all right, the average velocity, you can kind of think of as average velocity as slope. That's really what that is. So the average velocity would be the change in the position over those two time intervals, or that time interval. So we could say S of 3 minus S of 1 over the change in time, 3 minus 1. So again, this is similar to my example where I'm traveling. It's the change in the distance over the change in the time. So the change in the distance is the change in the position function over the change in the time. So S of 3 and S of 1, if I put those numbers into the position function and calculate that number, let's see what that gives us here. You can put this into your calculator, you'll get 80 feet. It's also in the graph below. That's what this graph is showing us, is the graph of that position function. You can see at S of 1, the position right here is at 80 feet. S of 3, same thing. If you were to substitute that in for your time and calculate what position is 3 seconds after we've launched it, that's right here in the graph. That gives us 144 feet. So my change is going to be 144 minus 80 divided by 3 minus 1. So I'm going to put those numbers into my calculator. I'm getting 64 divided by 2, which gives me 32. So the average change over that interval, average velocity rather, is 32 feet per second. Let's do this interval. We're going to have the difference in the positions between 1 and 2 seconds divided by the difference in the times. And I'm going to get these values from the graph. S of 2 is right there. That's 128 minus S of 1, which we previously said was 80 over 1. So 128 minus 80, of course, just gives me 48 feet per second. So what do these numbers mean geometrically? Well, remember, these are really slopes is what they are. So in the first example here, 1 to 3, that would be the slope of the line that goes through the points where t is 1 and t is 3. So I'm going to connect those. And the slope of that line is 32. That's what we're saying with this value. The second example was from 1 to 2. So from t equals 1 to t equals 2 right there. Notice that if I connect those 2 points, the slope of that line is a good bit steeper, and the slope of that line would be 48. So what we're going to do, we're going to stop here, and what we're going to do tomorrow in class is we're going to look at what happens if we keep bringing these points closer and closer together, and that's going to get us towards the idea of what we mean by a limit. So make sure you bring your notes with you to class, and we will finish this section up tomorrow.